Good morning, everybody, and thank you for taking the time to join us today. So my name is Mark Britton, and I'm the Marketing Manager for the Syngenta potato portfolio. During the course of this week, Syngenta is running a series of virtual potato science live meetings, and I'll be chairing those each day. As you're aware, today's topic is blight management, and the Syngenta presenters for today are Michael Tait and Harry Fordham. Just be useful perhaps to give you a reminder of the other sessions that we've already run and will be running this week. So on Monday, we had a session on seed and soil-borne pathogens. And yesterday, we had a session on soil pest management. So both of those, if you weren't able to attend, then both of the recordings for those two sessions can be found on the Syngenta UK TV YouTube channel. Tomorrow, we have a session on biostimulants. And on Friday, we have a session on sustainability. So if you'd like to attend those and haven't already registered, then there is still time to do so. If you visit the events page of the Syngenta UK website, you can register for those remaining two events, or so you can visit the Syngenta UK TV YouTube channel and look at some of the earlier sessions if you weren't able to attend those. So before I hand over to Michael, I'd just like to run through a piece of sort of the obligatory housekeeping. So Syngenta as host, we will record the webinar via Zoom, and the recording will be published on the Syngenta UK TV YouTube channel, and that'll be after the event. No recording by anyone else or by any other means is permitted. If you have any questions, then please send them in using the Q&A function. So don't use the chat function. So make sure you use the Q&A function. And we will also send an email tomorrow with information on how to apply for BASIS and Enroso points, and also include a link to a feedback survey. So with that, I'll now hand over to Michael.
Good morning, everybody. Let's just share my screen here. Quite sure why that's done that, but still. Yes, good morning. Sorry about that. Slight technical glitch there. I'm Michael Tait, Technical Manager looking after the potato products and also veg product area. And this morning I'm going to talk to you a bit about blight. I'm going to start off with talking a bit about the blight situation with regard to the genotypes. So I'll be using some of the information gathered by the AHDB and through John Hutton Institute. So for those of you who were able to attend that, there'll be a bit of repetition in this for you. Also, hopefully, a useful reminder of some of the information that was given in the AHDB conference. And then I'm going to go on and talk a bit about the trials we had last year at Eurofins and show some of the data from that before handing over to my colleague Harry Fordham, who will talk to you in a great deal more detail about the application technology that we've been looking at and spraying techniques. So just a reminder about last season, and again, thanks to AHDB for this information and to David Cook in particular. You can see that there were blight epidemics across the country. It wasn't as bad a year as the previous year, 2019. So you can see the little figures in brackets indicate how many outbreaks they had in the 2019 season compared with 2020. So a bit of an easier season in 2020 for managing blight. The thing that quite a lot of attention is paid to is to how late blight is evolving. And you can see from this wonderful graph that over the years, it has indeed changed quite a lot. And that we must expect to continue, and is one of the reasons why we have to be very vigilant about how we manage blight through the correct use of the products. So just a few highlights here. EU 36 has increased in its population across the country. EU 37, which shows tolerance and resistance to fluazinam, also increased, although obviously the use of fluazinam in the market has been reduced a great deal compared to what it would have been historically. 6A1, which has been one of our sort of been in our marketplace for a long time, that sort of remains static according to the testing, whereas 13A2, which has resistance to the phenylamides, has declined in the population. You'll notice along the bottom there the number of isolates collected. So 2020, many fewer isolates upon which to make these judgments than in the previous season. But nevertheless, I think this gives a very good snapshot to what's happening with genotypes in GB. Just a few extra sort of pointers here, again using some graphs to show where the isolates were being picked up. And I think the particularly EU36, which came in a few years ago now, has become pretty widespread. And this aggressive genotype pretty much across the country, whether it's right down in the east of England, across into the west and up into Scotland now. Within continental Europe, 36 has also increased, but new genotypes are also arising there, which we haven't really had in any numbers yet, for example, EU41. And some of the older types, particularly 13A2, have declined not only here, but also in mainland Europe. So we've got a very dynamic situation going on, and it's useful to have this sort of collection of samples and a view as to what's happening, because it sort of telegraphs as early as possible potential problem areas. You'll also be aware that the John Hutton Institute over the last few years has done a series of tests to see whether any of the really key products that we have for blight control are showing any reduction in their activity against blight strains, or when any of the strains that we're aware of at the moment are showing signs of the development of resistance. And you can see here in this little chart, you can see the years in which they have tested various materials. So for example, our product mandipropamid has been tested over these 3 years. And some of the other materials, for example, oxythiopiperine, which has only just come into the market, they've only done testing in 19 and 20. So it gives you an idea of how they're doing and how they're kind of monitoring what's happening with the fungicides that are available for us for controlling blight. I'll just highlight one set of results because this is quite important, obviously, for us with REVUS. We've had testing in 2018, 2019 and 2020, and they've tested EU36, 37 and 13A2 over that time. And basically the message from the testing over these 3 separate seasons is that mandipropamid is maintaining its high level of efficiency against all of these potentially aggressive pathogens, and that hasn't changed over this 3-year period. So that we can remain confident that at the moment the product is working, that we are showing the right approach with our following the FRAC guidelines, alternating materials with different modes of action, or combining products with different modes of action to try to fend off the risk of developing resistance. Yeah, I think that slide probably summarizes the important points there about following the FRAC guidelines as far as humanly possible and making sure that we continue to have effective materials. And one of the things that will have helped us a bit in that regard has been the decision within CRD not to withdraw mancozeb on the same timeline as the rest of Europe. So there is potentially another 3 years in which mancozeb, either as a straight or in combination, could possibly be used in the UK market. Now, of course, CRD, HSE have reserved the right to terminate that at any point in those 3 years, should it be necessary to do so. But I think it gives everybody a bit more time in which to consider how to put together programs that where they don't rely on having mancozeb-based products. So I'd just like to turn now to say a little bit about the trials that we ran in 2020 with Eurofins. We'll all remember it was a bit of a strange year with the beginning of the COVID crisis, and most events last year seemed to be cancelled. Possibly one of the exceptions for field days was the Blight event late in the year at Eurofins, which I myself missed because I thought all events were going to be cancelled. And I was not available on the day they eventually held it. But a lot of people did go, but I did manage to visit the site earlier before the event was undertaken, and had a look at all of our plots and could film some of the plots for a video. But what I want to do now is just to tell you about one of the trials before passing on to Harry for him to talk about the other important piece of work we did on application technology. For the last few years, we've run trials which we call the intrinsic activity trials. The idea of this experiment is to test particular products throughout the season in a continuous non-commercial program to see intrinsically how active they are and how good they are at protecting against blight in a high pressure situation, which of course you have at the Eurofin site because they inoculate. We also wanted to look in particular at using REVUS in combination with the drift retardant, where we've seen in the last few seasons quite a lot of success with this approach, getting more product into the canopy and really helping with the activity of REVUS in that way. So just a quick highlight of what was done. It was the crop was Melody, so it's quite a squat, leafy sort of crop. Planted in May. It was inoculated with these genotypes. So you've got the pink 6, which is very common, blue 13, which we saw from the charts from AHDB, is in decline. 37, which is around about 10% of the population, and this aggressive strain 36A2. And 2020 was the first season that Eurofins have agreed to inoculate using this particular genotype. Previously, they didn't, but in 2019, by the end of the year, this had become the predominant genotype on the site. You can see there we had 11 treatments, fairly regular program, bit of a problem late in August when the weather was particularly bad and unfavorable for spraying. This was our treatment list. So we've included in there REVUS on its own, or REVUS with Crusade or Sterling, the drift retardant. We've a new product we're looking at, which we also included, and two of our more established products, Carriol Flex, where you've got the combination with cymoxanil, and Amphor Plus with difenoconazole, and some important products in there as competitors. Again, we didn't include Zorvec and Davia because we did not want to use it season long. As you're probably aware, we have a joint development agreement with originally DuPont and now with Corteva with the OXTP molecule, and within that it's agreed that we have to always maintain a strict sort of stewardship and resistance management program. So we know that the product works and we didn't want to expose it unnecessarily to enhancing the risk of resistance. You can see here that in the untreated, the blight epidemic developed really very nicely towards the end of July. I've not included all the application dates because some of them would have been before the blight actually started, but there were 11 in total. And you can see that for most of the program, the treatments have given nice control over that period. Just to highlight again, as we saw in the previous season, and I'll come to that in a moment, we saw really nice efficacy from using REVUS with the drift retardant. And the main reason we think we're getting that is because the nozzles they use for this are reasonably drifty, and we're getting a lot more product into the canopy where you need it. And of course, once it's in the canopy, REVUS locks into the leaf structure and gives really nice control. So you get that lock and flow benefit from the product. The second year running, we saw relatively weaker performance from these two materials here, but you can see that most of the products are working pretty similarly, particularly later in the season after the end of the application period. Now, it's always quite nice just to have a bit of an overview, and I like using area under disease progression curve to show this because it highlights how much disease has developed in the plots throughout the whole season. So you can see here very clear difference with the untreated being completely sort of destroyed, REVUS on its own, and then here you've got REVUS with the drift retardant. You've got here our new product which we've got in development, Carriol Flex and Amphor Plus. Good, strong, robust performances from these combinations, very similar to some of our key competitors used in the season, and possibly just this one here these ones here looking a little bit weaker in this long-term program. But of course, it's not a commercial program. It's basically looking at the intrinsic activity over time. just highlight going back to 2019, where we ran a very similar trial, and the results are broadly similar to ones we had in 2020. Again, we had REVUS in there. We had REVUS with a drift retardant. We included in 2019 Tait, and then we had some of our other key products, Carriol and M4 Plus, again, performing extremely well in this trial. So that really brings me to the end of my section. If you have any questions, do put them into the question and answer function, which was mentioned by Mark at the beginning. And I'd now like to pass over to Harry Fordham to talk to you a bit about application and nozzles.
Thanks, Michael. Good morning, everyone. I hope you're all well and your office is slightly warmer than mine. Nice and chilly here. Bit more snow, but it's melting slowly but surely. Michael's done a really good overview of the Intrinsic Blight trial we did, just looking at sort of product performance and product comparisons over a season done at Eurofins. To build on that, we at Syngenta are very proud of the fact that we have a lot of expertise and knowledge on nozzle technology and realise that actually a lot of the work done by the product is actually done importantly by the people applying the product or how that product is applied. And as you'll know, I've taken on the role of that application technology specialist, and we are looking at different nozzles and different nozzle technology and how that can impact how different products interact with the crops and their target species. So just to reiterate the importance of application and why we believe it to be so important at Syngenta is because, you know, we would suggest that, you know, we can have a difference in the product efficacy of up to 50% if, and I'll show that to you later, if you apply the product incorrectly. And that attention to detail can have a massive impact. And we've got this this graph here on the left-hand side, where it sort of breaks it down into three different areas. Timing or weather, obviously explicitly important. If we get the timing incorrect, be it too late, too early, products aren't going to work as well as possible. Weather, you know, we all know about rain fastness for products, but also excess humidity and wind. If it's too windy, we're going to struggle to make sure the product hits the target. And I think with things like potatoes and potato blight, timing of application, as we know, is extremely important. And that's why we thought we'd go forward and look at how new nozzle technology can impact that. So mechanical, we have sprayer setup, be that things like tire pressure, boom lubrication, boom leveling, that kind of thing. And then fine tuning. This is sort of your making sure your nozzles are calibrated correctly, and if you've got some modern technology like pulse width modulation, that all interacts correctly, those kind of things. But we know a lot of different impacts affect application. But today I'm mainly going to focus on nozzle choice and looking at how we investigated different nozzle selection and the impact that would have on blight control in our blight trial in collaboration with Eurofins. So what were the trial objectives? The trial objectives in 2019, so this was last year, were to investigate whether or not a 90% drift reduction nozzle could deliver blight control that was equivalent to and or better than the current recommendation, which is the Syngenta potato nozzle. It would be to compare the new 3D90 being launched by us at Syngenta to other 90% drift reduction nozzles, so the Leckler ID3, against Syngenta potato nozzles, so our current recommended advice, and a flat fan nozzle. Highly regarded as sort of the industry standard. It's a good benchmark from which we can test other application techniques. And then also, as Michael mentioned, we looked at the impact that potential drift retardants could offer, if they could offer any benefit on blight control, and if they did, what benefit was it, and how did it work, and how does it impact droplet spectrum, for example, coming out of the nozzle. And implicitly, this is what's really important at the bottom here, is and something I'm very passionate about, is that these application trials are carried out and must be carried out using as close to a farm standard sprayer as possible. And we use a small mounted sprayer on the back of a fully fledged tractor, and that's because that replicates as close as possible what operators and growers are doing out in the field. As you know, when we trial new products, they're done with a hand boom with a very fine droplet spectrum in very good circumstances. And unfortunately, due to the compromises we have within agriculture, we can't do that every time in real life. So I'm very passionate about enforcing the fact that we use a real sprayer in as close to realistic circumstances as possible. So just an overview of the nozzles that we selected, and I'll explain why we selected these. We've got 4 nozzles down the side, a Leckler ID305. So this is an air induction nozzle. It's vertical. It is a 3-star nozzle from 2 to 8 bar. It has 4-star rating at up to 3 bar as well. We have the Syngenta 3D9005, and you can see a sneak preview of one here. That has got a 55-degree angle. It's a 90-degree fan angle, but it's a low drift angled fan nozzle is a good overview. It's going through our SILSO recommendations in the next few weeks. And our target and our ambition is that will be a 4-star LERAP rated nozzle. And like I say, it's going through at the moment, but all the testing we've done so far, we're confident we will get that. We then have here the trusty and reliable Syngenta potato nozzle, an 05 here. And remember, that's got a 30-degree angle, very slightly reduced drift angle, flat fan type nozzle, and we get 3-star rating at 1 bar. And then, of course, the old and recognizable flat fan nozzle. And what I thought I'd start with is my new farming technologies team. So Joe and Rory thankfully went up to Eurofins on one of the days when they applied the products. And we have some really cool glow-in-the-dark dye called Helios Dye. And that can allow us to give some really good imagery of actually what happens when the droplet hits the leaf of the target. And that gives us some really good perspective as to how our droplets and our nozzles are interacting with the target in question. So obviously, in this respect, we looked at lots of different photos, lots of different applications, using both with and without the drift retardant, along with REVUS, should I add. So this is our staple. This is our initial application that you guys will recognize, I'm sure. Excuse me. But this was done with REVUS and a standard potato nozzle. Remember, this has got an angle, sort of flat fan-esque. But it's got a very small droplet spectrum. And one thing that's important to remember about when you have a small droplet spectrum, i.e. the VMD is relatively low, the droplets don't have lots of momentum. They're not very heavy, they're small. So you tend to get a lot of product in the top of the canopy. So here we have the growing point of the potato. This is the top. Top right is the middle of the plant, and then at the bottom we have at the bottom of the plant here. And you can see the majority of the product has been landing up the top here. But what's also important to recognize is lots of small, fine droplets. When we add the drift retardant, you can see that we're getting nicer, bigger sized droplets at the top of the plant, growing point, the top, the middle and the bottom. And because we've got bigger droplet size, we're getting more droplets down into the middle and the bottom of the crop. And that's, often, as you will know, where humidity is high and blight infection risk is quite high in these sort of top and middle sections of the crop. So it's good that we're seeing an added effect from using the drift retardant of increasing those droplet sizes. And we did some really good droplet spectrum analysis with our colleagues at Jellis Hill. And what that showed is it took out the extremes of the droplet sizes. So it took out the really small driftable fines, which means that they would make this nozzle less prone to drift. This is what happened when we included the ID3 nozzle. And, as expected, bigger droplets, more droplets, the growing point, less droplets at the growing point, more consistent through the top, but a lot more in the middle of the crop. And as I say, that's where the relative humidity is highest and most likely to increase blight risk. And this was the ID3. So remember, this is a straight down nozzle with the drift retardant. And actually, drift retardant is doing a great job of evening up the droplet sizes. So you can see we're not getting extremes. There's very few small droplets, very few very big droplets, but really nice even consistency throughout the height of the plant. So from growing point to the top to the middle, right down through to the bottom, and we're getting really nice even droplet spectrum using the drift retardant. And of course, what you've all been waiting for, which is the 3D90, the Syngenta 3D90 nozzle. Now remember, this has got that 55-degree fan angle and good, decent sized droplets, which for a product like REVUS is great because we have a bit of movement within the leaf. Nice, even application throughout. So we've got growing point, remember, the top, the middle, and a little bit down at the bottom here, but really good, even distribution throughout the plant. And there's two reasons for that. There's a combination of it's got a bigger droplet size. So as I said before, it's heavier, it has more momentum, is less likely to drift, but the angle means we get good coverage across multiple targets that are facing in multiple directions. And when we add in that drift retardant, you can see very few smaller droplets, as you'd imagine, because it takes out the extremes of the droplet spectrum, takes out the driftable fines, but we're getting good, nice, even deposition throughout the plant similarly. So we're seeing a benefit visually of adding in the drift retardant, sorry. But actually, what does that mean in the field? So the trial we chose to take place was done, like I said, in Derbyshire, like Michael said, with Eurofins, all managed and applied and assessed by Eurofins, done with Melody, planted in May, and emerged in the beginning of June. We did 7 different applications. The first was on the 2nd of July, and the last was on the 17th of August. The first 2 applications were done with a Zorvec Kurzite tank mix with just a potato nozzle to ensure we got even distribution of blight through all the plots. We then had 5 applications of REVUS in a row, and just to remember that this was an inoculated trial. So we're under relatively high blight pressure and trying to test the products test the nozzles to their extreme. As I said before, I'm very passionate about ensuring we use a real sprayer and real on-farm practice, and this is what was chosen. It might not be as big as some of your guys' technology, but it is still a boom. It is still on a tractor. We are doing our best to keep it at 50 centimeters above the target. But you get quite a good illustration here of some of the untreated plots at the end of how blight was going through some of the plots, and up this end as well, that was untreated. So we're under quite high blight pressure, and this photo was taken in the middle of July. So we're relatively early on in the process here. Also, a little bit of an overview of the 3D90, because some of you may have heard about it, may have seen a little bit about it, but as we know, our ambition with application technology is to maximize efficacy without reducing work rate as much as possible, whilst minimizing our effect on the environment, whilst reducing drift. And also, when we think about drift, it's worth bearing in mind that it's not just the environment we've got to think of, which is obviously top and center of our minds, but actually you as operators, advisors and farm managers, if you spent money on this product, you want it to do as much as possible. And if you're reducing drift and it's hitting the target, you are maximizing the value for money from that product. And also, like I said before, I think timeliness of application with blight fungicides is extremely important. And if we can minimize the amount of down days we have, i.e. used when the weather's compromised, be it slightly windier conditions. Now, I can't condone spraying in windy conditions, but we know times where we've got a full tank mixed up and times are slightly compromised. Using a drift reduction nozzle is likely to help out in those circumstances. And then just an overview of the 3D90. So we get a cool little picture here. You guys may have seen prototypes, which looked a lot more ugly than this, but I think this is sleek. It's a thing of beauty. It works really nicely. It has a snap lock fixed cap at the top here, which makes it lovely and easy to fit onto your onto your crop, onto your sprayer, sorry. Importantly here, it's got a pre-orifice to meter the flow. That's how we get our drift reduction capability. The benefit of that is that it's able to be used on brand new pulse width modulation sprayers, because we know that air induction sometimes doesn't work on that side of things. But here we have the ability to use those, which is fantastic. We have the body that has that 55-degree incline, as described earlier, and a unique tip that creates a nice even fan angle of around 90 degrees. That means we don't have excess big droplets coming out the side or small driftable fines. Again, just to remind you of the nozzles we looked at, the Leclerc ID3, which is up to 90% drift reduction, the 3D90, as explained, the 90% drift reduction nozzle, the Syngenta potato nozzle, and of course the flat fan. So this is the treatments. As I explained, the first two applications were done with a Kurzite Zorvec mix using standard potato nozzles, and we kept that standard across all programs, so we're at an even benchmark to kick off. And then the last 5 treatments were either with or without the drift retardant, and with different application technology. So here we have potato nozzle, ID3, 3D90, and flat fan, all at 200 litres a hectare, all at the same forward speed. And what was really important to remember, everyone, is that this blue line here is the untreated. So you can see up to the end of August, we were at 100% infection. But the blue stars denote all the different applications, and the different coloured lines are the different nozzles. And I appreciate that it's difficult to see any differences at this rate, but if I zoom in on that, we can see here that the orange and dark sort of red line here, almost brown, that's the potato nozzle and the flat fan. And then here we have the ID3, the Leclerc ID3, and the 3D90. What's important to note is these are all without drift retardant, with the 3D90 performing the best, using the same metric that Michael is using. And then here we can see at the bottom, all nozzles showed an appreciable increase in levels of control using the drift retardant. Importantly, though, from my perspective and the Syngenta perspective, that Syngenta 3D90 is still performing the best, albeit those differences are slightly smaller. But encouraging to see that 90% drift reduction technology works, but also adding a drift retardant can have a beneficial impact upon that. And then finally, this is the area under disease pressure curve, which Michael alluded to earlier. But you can see that the 3 significant difference treatments are the 3 that include the drift retardant. And the one that's performing the best, as alluded to earlier, is this dark blue one, which is the 3D90 with REVUS plus drift retardant. So we're seeing real benefits from using it, but also we can be confident that these 90% drift reduction nozzles are working well. So in summary, for the second season running, we're able to show that REVUS through 9% drift reduction nozzles deliver excellent blight control. We can be confident within that. And like I said before, within the 3D90, we saw a benefit of using REVUS with drift retardant. But with the drifting nozzles, this benefit was more pronounced. Now, I think when you think back to our hypotheses that we were trying to challenge at the beginning of the presentation, the first one was, does 90% drift reduction technology work on blight? We're confident that it does. The second one was, does the 3D90 work well on blight? And yes, we're confident that it was. And the third one was, does drift retardant add anything to our blight control? And through both years of trials that we've done, and these are replicated trials, we can be confident that we're adding a level of control using drift retardant. And I think that's because more droplets are hitting the target at a more assured level. So that's my application messages. Thank you very much for your time, everyone. I'm going to pass back to Mark, who is going to lead the question and answer session.
Thank you very much, Michael and Harry. So we have had some questions come in. So just a reminder really to everybody who's on the call who has a question, still an opportunity now to submit those questions via the Q&A function. I think we've got about 4 questions so far. So yeah, please submit any questions you have, and we'll answer them now. So first question, this is one for you, Harry. So if you could choose sort of only one, what would your nozzle recommendation be for spraying if you're sort of coastal proximity blight spray application?
Yeah, a good question. I think with it being coastal, obviously weather can be changeable and changeable quickly. And we are confident that the 90% drift reduction technology works. And so I would be alluding to a 90% drift reduction nozzle. And from the work we've done, historically, using an angle on those things, on blight products, works extremely well. And that's why the potato nozzle had an angle on it. And as a result, the 3D90, which has got an angle on it, would be a great option for that. The only caveat I have to that is the 3D90 should be available soon, but we are just on a moving timescale with that. So my first choice would be a Syngenta 3D90. If that isn't yet available, then I would recommend an angled 90% drift reduction nozzle, such as a Leckler IDTA type nozzle. So we're confident that they work well, and that's what I would choose in that situation, because I think in coastal proximity you're under high pressure because you get the sea fog, but you also are at risk of a lot more wind as well.
Thanks, Harry. So we've got a few more questions related to nozzles. So are the potato nozzles still available?
Yeah, that's a good question. So unfortunately, Hypro, who are our manufacturing colleagues, have chosen to discontinue the potato nozzles. As a result, there are a few left out within the distribution channels, but once they are all sold out, they're all sold out, which was another reason we needed to ensure that our application advice was up to date. So yeah, unfortunately, that was slightly out of our hands, but yeah, they aren't. But they aren't going to be available going forward. No.
Thank you. A couple of questions around best practice with the nozzles. So looking at the, I guess the 3D90, but also just in general, what is our best practice advice? Is it still to alternate sort of one back, one forward?
Yes. Yeah. Sorry, Mark. Yeah, it is. So I should have put that in. Apologies. But yes, it's to alternate them forward and backwards across the boom, like we do with the potato and the 3D nozzles. The only caveat to that is behind the sprayer itself, the physical machine, the chassis of the sprayer, because of the angle on some models, they all need to be pointing backwards because you hit the body of the sprayer with the spray. But across the length of the boom, we would recommend alternating forward and backwards. Yes.
Another one for you, Harry. So lots of interest obviously in the application, but hopefully got some in a minute for Michael as well. So does the 3D90 work well with pre-emergence applications?
Yes, yeah, it does. We've done the majority of our trials in pre-emergence applications, and it works extremely well. The angle, again, really good for good coverage around the clods. The nice big droplet size is great to ensure spreading across the soil and reducing drift. And in terms of potatoes, when we've done work using drift reduction nozzles, they work extremely well in potatoes because we don't see the effect on the side of ridges, which we sometimes see using more drifty nozzles, where if you're spraying on a windy day, you sometimes see on the leeward side of the ridge more weeds growing because you're getting an element of drift away from the side of the ridge. Because it's important to remember that best practice is to keep boom height at 50 centimeters above the target when using a 50 centimeter nozzle spacing. But if we're using, if we're spraying potatoes on potato ridges, obviously your target is the top of the potato ridge. So you could be at the bottom of the potato ridge and on the side of the ridge, anything from sort of 70 to 80 centimeters above it. And using a heavier, bigger droplet can add to the accuracy of your product, application.
Thank you for that. So just a reminder really to people who are listening, if you could submit any questions via the Q&A function. We have just had one come in via chat, so we can manage it, but it's easier if they're all kept in one place. So if you could submit via the Q&A, that'd be helpful. Thank you very much. So a couple of questions now. I think hopefully, Michael, you might have an opportunity to to come in and comment. Just moving away from the specific pieces around nozzles and application. So in the trials, does 100% infection refer to every plant having an infection to any degree, however small?
No, I think basically the way that Eurofins do their assessment is that it's the percentage of the leaf area within the plot that's damaged. So obviously it's a visual judgment, but they have a lot of practice in doing this, and it tends to be the same people making the assessments again and again through the course of the season. So although there may be differences, those differences are consistent. So no, it's more a percentage of the plot area that's damaged by blight. So when you get to 100%, then essentially every plant within that plot would be severely damaged, and a lot of its leaf area would have been killed by the disease.
Thank you for that. A question around sort of the drift retardants that we've been trialing with REVUS and the sort of Mandy products. So do those drift retardants add anything to rain fastness? And contained in that question as well, is 200 litres per hectare sort of water still a sweet spot for blight spraying?
I think the first bit is about does it add to rain fastness? I don't think we haven't specifically studied that, but if you think how the product, the drift retardant is getting more of the product onto the leaf, and we know that when REVUS is on the leaf, it's going into leaf wax, and at that point it then becomes rain fast very quickly. So no, I don't think intrinsically the drift retardant is of itself helping with rain fastness, but it is helping to get product where you really want it. So indirectly it's having an effect, because obviously the product can't be rain fast if it's in the wrong place. So I think it does have an indirect effect. In terms of the water volume issue, I think I'll probably ask Harry to comment on that. I mean, I think from a practical point of view, a lot of people are using 200, but whether it's absolutely the best, I don't know. We haven't done enough trials that I'm aware of looking at different volumes.
Yeah, so we've, over the last few years, prior to this year, so over the last sort of 2 or 3 years, we did do some work looking at water volume and going from 100 to 200 up to 300 or 400 litres a hectare. And we definitely see a benefit of going at 200 over 100. You can get a slight benefit of going at 300, but it's negligible compared to 200. We still see 200 litres a hectare for blight applications as the sweet spot for the moment. Just, you know, increased droplet size, increased coverage, that kind of important stuff when we're talking about such a big canopy crop such as potatoes.
Thank you both for that. So a question around, again, sort of drift retardant. So looking at drift retardant through the eyes of IPM, can we extend intervals when using it?
I think not. I think the main thing we're trying to do is to get the product on target. Most of these products are not, you know, they're not lasting for really long periods. I mean, and obviously if you're getting the product on target, it doesn't make any difference to the product's basic activity will last a certain number of days. Putting it with a drift retardant won't make any difference to how long it's lasting. And the other fact, of course, is that during this period, the crop is growing, and so new areas of leaf and leaflet are becoming or developing and are not treated unless you've got a highly systemic material, which most blight products aren't.
Thank you very much. So a question that's probably for you, Harry. So will the new 3D90 nozzles fit on a quad body?
Yeah, they do. They are, the cap size is not exceedingly big. It's a standard sort of cap size, and yeah, they fit on a standard bayonet fit body. Yeah.
Thank you. So you had a few questions. Actually, Harry, if you could just summarise again, we've had a few questions come in. Just a reminder about how the 3D90 nozzles should be placed along the boom, and also just a reminder when they'll be available.
Yeah. So for the setup along the boom, we would recommend forward and back across the boom, as we've done with the potato and 3D nozzles. The only slight caveat to that is that potentially behind the chassis of your sprayer, you may need to point them backwards because the spray, because of the angle, the spray may hit the physical chassis of the sprayer, but that varies from machine to machine.
Thank you. A question again around drift reduction nozzles. So if they're good for pre-em as well as blight, should we be looking at using a drift retardant in our pre-em herbicide as well?
That's a very good question, and it's one at which we have investigated over the last. We did trials last year, and the trials that are in the ground this year, we've had a look at. Last year, we didn't see a big improvement in control using the drift retardant, but I'm going to caveat that with the fact that we didn't see huge differences last year due to a number of reasons. As we know, autumn 2019 was extremely wet and extremely tricky. So a lot of our pre-em products actually just generally performed well. So we haven't seen a benefit yet, but I wouldn't say don't do it, but I don't see the benefit at the moment.
Thank you, Harry. One for Michael, I think. So this is one about sort of blight pressure and when it's high, a bit of a view on some products. So specifically, somebody's asked, so when blight pressure is high, what are your views on sort of the following products in terms of their efficacy? So Zorvec, REVUS, Infinito, and Roundman Top.
An interesting question, and one which I think I can give a relatively straightforward answer on in terms of not necessarily an exact ranking, but certainly there is little doubt within the industry that currently OXTP is the most active material against blight that is available. On the other hand, we're also aware that because it's very high level of efficiency at low rates, it does run the risk in the longer term of developing resistant blight strains. So yes, I think under high pressure, Zorvec would be a good choice. But within the program, you have a limited number of treatments that you can make, and it's obviously key not to overexpose a very useful material too often. So again, you've got very good materials that have been extremely stable over time. For example, REVUS, which has been used for many years now with no change in sensitivity. So I think ranking them, you're going to need all of these tools under high blight pressure situations is I think how you need to look at it. Certainly at the moment, the most active is probably OXTP and followed by mandipropamid. But within the program and high pressure situations, you're going to need all the tools that are available to you if we get a bad season.
Thank you, Michael. So again, just for those people that are sort of joining us today, we've got one more question left to answer. So this is your final opportunity, I guess, to submit any questions via the Q&A function. So let's answer the final question that's currently on the screen. So how does the water volume affect the efficacy of fungicides depending on canopy size?
Yeah, that's a good question. We haven't explicitly trialed this because what we tend to do is, as we've done in these trials, is look at progression of disease throughout and then look at total disease using that area under disease pressure curve that Michael uses. But in theory, if you're aiming for a smaller target, you know, early on in emergence, when it's that small rosette stage, then using a smaller water volume, such as 100 litres a hectare, would be fine. And it's trying to find that tipping point where you go from a smaller plant to a bigger plant where you change from 100 up to 200 litres a hectare. And at the moment, we haven't really confirmed where that is. And that, you know, could be some work we could do going forward. But I would suggest in general going at 200 litres a hectare. And when we're using these sort of protectant type products, 200 litres a hectare, maximising deposition and coverage on the leaf is the best way to go, because we're maximising product onto the leaf. And it sort of comes back to why the drift retardant's adding something is if we're hitting the leaf, we're maximising protection and ensuring most efficacy from our products.
Thank you, Harry. So you had a last minute, as you were finishing your summary there, we had a final question that's come in. So this is around pre-em herbicides. So pre-em herbicides on potato ridges, which would be the preferred nozzle choice?
So if we're talking, that sounds like it's for broadcast application, not band application, but for broadcast application for potatoes, then the 3D90 has done very, very well in trials. Again, like I say, that using a 90% drift reduction nozzle for pre-ems on potatoes maximizes the evenness of deposition across the ridge and down into the bottom of the ridge as well. So I would suggest the 3D90 nozzle or our previous recommendation for pre-ems, which was the TJet TTI nozzle, which again, 90% drift reduction, works extremely well by ensuring even deposition across the top and down the sides to the bottom of the ridge as well.
Thank you for that, Harry. So we have, well, thank you both. Anyways, to start with Harry and Michael, thank you both for your presentations and answering those questions today. I'd also like to thank everybody else who's joined us today. One, for joining us, but two, I guess, for your active participation. So it's great to have the questions that we get submitted at the end. Obviously, you can't meet face to face, so being able to have questions submitted and be able to respond to them, I think that's where sort of a lot of the real value comes in these sort of webinars that we're running. So thank you for submitting your questions and joining us today. So information on how to apply for basis and then ROSO points will be sent in a follow-up email. And again, it's really important that we get to hear your feedback. This is a new way of working for us. So feedback on, I guess, how the events run versus the usual face-to-face meetings we have, and also sort of the content. So yeah, we're striving to make this, or what we deliver, relevant for customer needs. So please submit feedback to the survey that comes out. Just a reminder that we do have, again, so tomorrow a session on biostimulants, and on Friday a session on sustainability. So you can still register for those events, and you'll also be able to go back and look at previous meetings that we've held and the recordings that will be on the Syngenta UK YouTube channel. So thank you again for joining us. Enjoy the rest of the day, and hopefully you can join us tomorrow. Thank you.
Thank you then, everyone. Thank you.
So,